Hello all, welcome to my channel. This is part 4 of the video series that we are doing on Ray. So we have already seen what is Ray, how we can integrate Ray in Spark, and we also understood Ray from a Spark developer's point of view. In this last video on this series, I will be discussing about the options that we have of running Ray on an AWS environment. So as we can see, Ray can be used in AWS on different systems. Like it can be used on EC2, it can be used on EMR, EKS, SageMaker, and Glue. So let's discuss in one by one what are their pros and cons and why we should be using one over the other. So uh, Ray we can install on EC2 and then run. Again, we will have full control in sense like we get to let's say all the binaries, all the architecture, everything that we want to have, we have full control of the EC, so we can EC2 up so that we can do those things. There is no managed service premium cost because, for example, let's say if we are using EMR, we pay extra cost for the EMR service. That will not come into this picture in if we are running Ray on EC2. It has direct integration with Ray for quick launches and also supports heterogeneous clusters like easy integration with EFS and S3. The cons is that we will have to do everything ourselves, so it is a high management cost. Then there is no built-in orchestration. We will have to implement it ourselves, and there is a steeper learning curve for this. And use cases is that, for example, if we have to do custom data analytics, for example, let's say Modin or Pandas on Ray for exploratory purposes, Ray on EC2 will be something that will happen. Let's say we had to do a migration or compaction jobs that we want to do, we can run it on EC2. Let's say we want GPU acceleration, again there we can use Ray on EC2. And prototyping Ray apps will help us with smaller cost or smaller footprint. Then Ray on Amazon EMR. So Amazon EMR supports, we can use Ray alongside Spark with RayDP for hybrid workloads. It is an ideal for data heavy pipelines that we have. And also this pros of this is that we can run full blown Spark features as well as Ray simultaneously on this. And it is a managed cluster lifecycle, so we don't have to worry about much. The support is there for a petabyte scale and can leverage spot instances as well. The cons is that setup is still complex. It requires configuring the cluster, and some bootstrapping has to be done so that the cluster has array on everywhere. Then we have to, if we are running very small jobs, then we will have a lot of overhead. Uh, this is for less focused on ML. This is for more for the data prep that requires pure training, and it is in multi tenant setups. Spark and Ray integration may need further tuning to avoid resource contention. Use cases for this is feature engineering. Then we have time series modeling that we want. We can do hybrid workloads like processing and ad hoc analysis can be done on this EMR on sorry Ray on EMR. Then we have Ray on Amazon EKS. So EKS is their Kubernetes platform where we can run Ray via kuberay and install the kuberay operator and then run whole Ray jobs or Ray service there. Pros is that it's very Kubernetes native, so we can run multiple versions of Ray. We can leverage the Carpenter or cloud portability. It's there. We can integrate with Prometheus Grafana or CloudWatch for monitoring. Other apps, if we have in our Kubernetes environment, we can run these along with that, and the pod failures and everything is happens automatically, and we can monitor it using the Istio traffic management as well. Cons are there that it requires Kubernetes expertise. We also need to pay the extra control plane cost for EKS. We will have to manage operators as well, which is not that much of complex, but yes, still we have to manage that. And if we add, let's say, storage, then becomes a challenge sometimes. And we will also have this will be a overkill if we have simple jobs that we want to run ad hoc basis. This is only for production, multi-service, multi-tenant systems that we want to use. It is very scalable. We can use it for RAG. We can use for multi-node distributed computing on GPUs, and we can run hybrid AI apps like fine-tuning 7 billion parameter models that are there with cost savings on spot nodes. Then we can run SageMaker, sorry, Ray on SageMaker. So this is a new feature that was launched by AWS, which allows us to run hyperpods for resilient and scalable clusters. So Ray support is there in that. So it will be a fully managed into an ML workflow, which handles data preparation, training, tuning, and deployment from one single pane. It is seamless integration with other AWS systems as well. For example, let's say if you want to do checkpointing to S3, that is already available. If you want ML flow integration with this, that also is available. And it supports heterogeneous clusters as well, like for example, GPU for training and CPU one for other things. And it is cost effective for busty workloads, but again, it will be costlier than the EMR option or EKS option that we have. The cons is here we don't have full control on the underlying infrastructure. We don't know what is happening inside SageMaker because we don't have access to the hosts. A higher cost is there, limited flexibility for non-ML tasks, like for example, data preparation and everything, and it is tightly coupled with SageMaker tools. So the portability part is not there. Let's say whatever built we have system we have built on this will not be portable directly to other vendors or other cloud providers. And the use cases that we can do is end-to-end pipelines for generative AI, fine-tuning LLMs. We can do it with using the SageMaker Hyperpod. Or let's say if we have use cases of running RL models, that also can be run on using the Raise RLib library. Ray on Glue. So this again is a feature of AWS Glue service, which allows us to run Ray as a serverless engine for scaling Python ETL jobs with Ray. So if we are not using, let's say we have workloads, let's say we are doing geospatial data analysis, let's say we have tools like JDAL or raster that is not distributed in a sense, like they don't work on distributed data. So they need everything to be present on the memory. So that kind of systems can be parallelized, made parallelizable in Glue using this Ray on Glue feature. This again is a serverless managed environment, a lot of integration with AWS services and pay per use build on DPU hours. Cons is limited to ETL. There's not much focus on ML here. Works with AWS data sources and data lakes. There are some quotas and timeouts, and the higher per unit cost is there compared to the EC2 sustained workloads. So there are different use cases for this as well. Like if we want to do ad hoc analysis or some we want to scale Panda workflows, we can use this Ray on Glue approach. So in summary, we have different models. Like example, we have service EMR, EC2 EMR, EKS, SageMaker, and Glue, where we can host Ray models. Management, EC2 is self-managed, EMR is managed cluster, EKS is managed, SageMaker is fully managed, Glue is serverless, and suited for. Then we have cost model. So the highest cost we will pay for most likely be the SageMaker one. The second highest will be Glue, then EKS, then EMR, and then EC2, or EMR can be even higher, not sure, but generally EMR will be higher compared to EKS. Then we have scalability. So EC2 we have to do manual scalability. EMR it is having high scalability because it can do, it has what you call integration with Yarn metrics. EKS because we are using if we are using Carpenter, it will scale up and down very fast. SageMaker it is totally managed, but it is although it is based on EC2, but it gives a high level of scalable solution. Glue, it is also again auto, like it is up to the quotas, it can automatically scale. And the integration that we have is this EC2, we can integrate anything that we want. EMR, it is only linked to S3 and Spark. EKS is linked with Istio and Grafana and other monitoring tools. SageMaker, S3 and pipelines we can integrate, and Glue we can integrate with data catalog. So these are the summaries of different options that we have to run array jobs on AWS environment. So hope this was helpful. Go and try out in your environment and figure it out which one is suitable for you. If this was helpful, do share and comment on that what you would like to see next, and do support the channel as well. Thanks.